Our last week of school. Whoop whoop, y'all made it. Okay, so today we are going to talk about identifying 2D and 3D shapes. So, as always, we're going to start it off with the video.
Three-dimensional or 3D shapes are shapes that take up space. They have 3 dimensions: length, width, and height. The world is made up of 3D shapes. They are all the things we can hold. Your book is a 3D shape. So is your soccer ball, as well as your birthday presents. Can you see how they each take up space? There are some features that are common across 3-dimensional shapes. These features include faces, edges, and corners. The flat surfaces of a shape are called faces. No, not that type of face. The edge of a 3D shape is the line where 2 of its surfaces meet. And the corner is where 2 or more edges meet. A corner can also be called a vertex. The faces of 3D shapes often contain 2D shapes that you may already know. Maybe you can recognize some of these 2D shapes as we go through a few examples. Here are some 3-dimensional shapes and their features. This shape is a cube. A cube has 6 faces that are identical, 12 edges, and 8 corners. All of the faces, edges, and corners are the same size and length. Can you see how each face of the cube is a square? This shape is called a rectangular prism. A rectangular prism has 6 faces, 12 edges, and 8 corners. It's very similar to the cube, except instead of all the faces being squares, they're rectangles. The opposite faces of a rectangular prism are always the same size. This shape is a triangular prism. A triangular prism has 5 faces, 9 edges, and 6 corners. Triangular prisms have 2 faces that are triangles and 3 faces that are rectangles. The 2 triangle faces are always the same size. However, some 3D shapes have more than just flat surfaces. Some have curved surfaces. But we don't call them faces because faces are always flat. This shape is called a cylinder. A cylinder has 2 circles on each end that are the same size, with a tube in the middle. It has 2 flat faces and 1 curved surface. The cylinder also has 2 edges, but no corners. Remember, a corner is where 2 or more edges meet. In a cylinder, there are no corners because its 2 edges do not meet. This is a cone. Not an ice cream cone, unfortunately, but it is the same shape. A cone has a circle at its base and a point at the other end. It has one flat face, one curved surface, one edge around its base, but no corners. This unique shape is a sphere. It's perfectly round, just like a ball. This means it has no flat faces, no edges, and no corners. Just one curved surface. How unique is that? That's what makes a sphere the perfect shape for a ball. It rolls around easily in any direction, and you can kick it without banging your toe on a sharp corner. Now that you know some three-dimensional shapes, perhaps you can spot a few examples of them in your classroom or outside in the playground.
Okay, so like we learned in the video, there are a couple of things that will help us know if the shape is going to be 3D or 2D. One of the things that all 3D shapes have are called faces, and faces are the shape's surfaces. So if you were to think about the base 10 blocks that we would use, the blue base 10 blocks that we used in class, those were all 3D, and they all had multiple faces. So the faces are just the soft, flat parts of it. And like they said in the video, it's not like your face. It's just called the face of the shape. Then the next thing are edges. Edges are the line segments where the two faces meet. So you see that this red part right here is showing you that this is an edge because that's where this face right here, and I know you can't see it, but on a 3D shape, you always are going to have faces that you can't see. You just kind of have to imagine it. So this edge right here is connecting this face and the other side of the face that you can't see. This edge right here is connecting this face and this face. So remember that edges are the line segments where two faces meet. And then the very last thing will be the little pointy spots right there, which we call our vertices. And these are the places where three or more edges meet. So if you put a little dot right here, like how they have a little dot right here, if you count the edges, you have 1, 2, 3. So that's how you know it's a vertices, because that's where three or more edges meet. Just like if we were to do it right here. We have 1, 2, 3. Or even down here, you would have this one, and then remember, you got to imagine that there's another line going. Just like how there's a top, there has to be a bottom too, because remember, it's 3D. So it should be standing out or popping out at you. This is an anchor chart showing you the difference between a 2D or in a 3D. So most of the time when you guys draw, like if we were doing using our base 10 blocks, and one of the assignments was for you to draw what you created, which was we did a lot. You would create it with your base 10 and then draw it. You guys would draw 2D shapes. So these are shapes that don't have a whole bunch of dimension to them. You see what you see. There's nothing behind it. If you drew your triangle, that's it. If you drew your square, that's it. Whereas with the 3D, remember, they're going to have edges, faces, and vertices. Whereas the 2Ds only have sides and vertices. Down here, you can see the difference, because if we look at this triangle and we look at this triangle, this one looks like it's standing out a little bit more. These little lines right here are showing you that this is supposed to be 3D. If you look at this one, this looks a lot different than this right here. This looks so flat, but this one, we have to use our imagination. It looks like it's I look like I could grab it. It looks like a box. Okay, so let's take a look at your first assignment for the week. This one is identifying pyramids. And I know maybe you guys have maybe heard of like the Egyptian pyramids, one of the 7 wonders of the world. So there are all kinds of different types of pyramids. And let's go over rules that make it a pyramid. So, what are some things that you know about pyramids? Think about it. What do you know about pyramids? Have you maybe seen them on TV? Maybe you have one in your house, a picture of one in your house? What do you know about them? Well, one thing that I can say is that I know pyramids are always going to have a triangle in it, for sure. So a pyramid has many triangular faces. And remember, our faces are the flat parts. So our pyramids have many triangular faces that meet at one point. The triangular faces all share one other face. So if you look at this, and like I said, this is a 3D, so we have to use our imagination. So even though we can clearly see 1, 2, you got to remember that there's another one on this side, and there's also another one on this side. And I know it's kind of hard to see on the computer since I can't actually have you guys doing this hands-on, but just work with me and try to use your imagination. Okay? So this right here says that not every object with triangular faces is a pyramid. So we do know that a pyramid has triangular faces, but every object that has triangular faces is not a pyramid. Pyramids may sometimes lay on a triangular face. So this one looks like what's laying down is a triangular face. Most pyramids that you're going to see is going to look like it's probably laying down on a square face, but this one is laying down on a triangular face. And some pyramids can look a bit strange. Now, if we were just to look at this and I asked you if that was a pyramid, you'd probably say no, because it looked like there's a big old chunk missing out of it. But as long as it meets the other facts about it, then it makes it a pyramid. So what we have to do is we have to go and we have to look at all of these. And you guys have another sheet. There's even more on this side. And we have to decide which ones are pyramids. And it wants us to count the number of triangular faces and write the total. Now the key word here is triangular faces, because if you look at some of these, I'm not seeing triangles. We all know what a triangle looks like, right? So we want to make sure we're only counting the faces that is a triangle. So now let's use our imagination. Okay. We know that a square has how many sides? 1, 2, 3, 4. Can y'all see that square right there that I'm drawing out? Okay, so it looks like that there is a triangle on each side of the square. So if there's a triangle on each side of the square and the square has 4 sides, how many triangular faces do you think is there? I'm going to say 4, and I'm going to have to exit out of the present mode. But I'm going to have to write 4 right here because like we just said, if it's on a square, it looks like it's going to have 4 sides. All right, let's try another one. What about this one? Let's use our imagination. So we have 1. Now we know for sure that it says what? It says, where was it where I saw? A pyramid has many triangular faces that meet at one point. So it's not a certain amount of triangular faces. So we still have to use our imagination. But like I said, what I would do is look at the bottom. What shape do you see at the bottom? I see a triangle. So a triangle only has 3 sides. So usually however many you see at the bottom, that's how many faces you're probably going to get at the top. So if I see a triangle at the bottom and it has 3 sides, how many triangular faces do you think this is going to have? Yeah, it's going to have 3. All right, I'll do one more with you guys, and then I'm going to have you guys do the rest by yourself. All right, let's do this one. This one looks like it's kind of hard. We're going to have to really use our imagination. Now, with these other ones, we can kind of just say, oh, I see a square. That must mean 4 sides. Oh, I see a triangle. That must mean 3 sides. But this one, I don't know. It's looking kind of confusing. So I'm going to have to use my imagination and act like I can see that sitting on my hand. So I'm going to act like I've taken this out of the computer and now it's sitting on my hand. So now I have to count how many I see. So I see 1, 2, 3, 4, 5. Now I see 5 triangular faces. Now I think there's more than 5 faces, but I only saw 5 triangular faces. It looks like it's the same one up here. 1, 2, 3, 4. Yeah, some of these is like you can look at it because now I'm looking at it again and I'm like, I think it's 5. Yes, I'm going to go with 5. So I just want you guys to try your best. I know some of these are kind of confusing because that one, it's like the longer you stare at it, the more faces you see. So just try your best on that one, on those. All right, let's look at this next page. So this next page says type a P next to the shapes that are pyramids. So you may have to go back over here and remember what makes it a pyramid. A pyramid is going to have triangular faces that meet at a point, and it's going to have faces that all share one other face. So if we look at this one, does it meet the criteria for a pyramid? Does it have triangular faces that meet at one point? Well, that looks like a triangle. That looks like a triangle. Yeah, it looks like all 3 of those are meeting right here at this point. So yeah, that might be it. Let's see what else. The triangular faces all share one other face. Well, 1, 2, 3 looks like they're all sharing this face right here. So yeah. So I'm going to put my P because that looks about right to me. Now let's look at this one. So let's see. First thing, pyramid has many triangular faces that meet at one point. I see 2 triangular faces, but they're not even touching each other. So does that mean that they're meeting at one point? So that means I don't even have to go any further because that's not a pyramid. So you move on to the next one. Okay, so let's do one more. We'll do this one together. So again, we need to make sure that they are all meeting at one place. It looks like multiple are meeting at one place. And they all share one face. Looks like they all share one face because they all have to share that bottom one down there. What do y'all think? So then we can write a P. Now this one I just want you to do your best. I'll read it to you, but I want to see what you think. So this says step pyramids are buildings that are made up of layers of stone. They do not have smooth triangular faces like the pyramids above because the faces are actually steps. How many blocks have been used in the step pyramid? Be sure to count the hidden blocks too. So it's not asking you to count this gray one over here. That'll be impossible. We can't really see that. It wants you to use your imagination and count these. Now, I know you know at this point that when it's 3D, you have to imagine that there are others on the sides that we cannot see. And I know sometimes that's hard to think about, but like I said, if you have to act like you're grabbing it out of the computer and holding it in your hand, then you'll know that if it's in your hand, you can turn your hand around in a circular motion and see all the faces and sides. So when you're counting it, like you know this is 1, you see 2, 3, 4, but you know there has to be another one on that side, 5. Then you go 6, 7, 8, 9. Well, you know it's not just 1 right here. It's probably going to be, well, there's 1. It's going to be 2 more. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Go back to this one, 12. We know that there's 2 more, 13, 14. And then you have to count this last one by yourself. So just don't stress out about it. I just want to see what you think. All right, the next thing that you guys are going to have to do is, and we've already gone over this anchor chart. I use it as one of your tips and hints. The next one that you guys are going to have to do is the investigating 3D objects. So I wanted to take a look at this really quickly when we investigate 3D objects. So I know I've been telling you and imagining if we were in class right now, we would make our own 3D object so you can see what it really looks like. But since we're not in class, we can just imagine. So we already know what faces are. Our faces are the flat things that we can see. We know that our edges are the lines that are connecting, right, two faces. And then we have our vertices, which are our little edge, which are our corners, okay? So it's going to ask you to name the shapes, and it's going to ask you how many faces, how many edges, and how many vertices. This one is also giving you an example of something real. So for example, this is a cube. Right? And how many faces? We have 1, 2, 3. Don't forget the bottom. 4. Don't forget the side. 5. And don't forget the very back. 6. 6 faces. How many edges? Let's count. 1, 2, 3, 4, 5, 6, 7. Don't forget the back. 8, 9, 10, 11, and this one right here, 12. Now I know that the edges can get very confusing when you can't do it in person. But like I keep saying, I don't want you guys to stress about it. I just want you to do your best. And I'm always here if you need extra help. And you can always watch this video as many times as you need to. Okay, then we go and we count our vertices, which are our corners. 1, 2, 3, 4. Don't forget the back. 5, 6, 7, 8. And we have 8. So that's the rectangular will kind of be like this one. So let's move on to this one right here. The cylinder. How many faces? Faces are flat, so we can't count. If you have a cylinder, it'll roll, right? This will roll. So what's rolling, we can't count as a face. The only faces is this flat and this flat. So you have 1, 2 faces. How many edges? Well, circles have no edges, so you have none or 0. How many vertices? Well, there's no corners also in a circle, so none. So let's do one more. Let's do the triangular prism. How many faces? So let's count. You got 1 on this side. 1, 2, 3, 4, and then don't forget the very back. 5. Don't forget the very back. Don't forget the very back. Don't forget the very back and the bottom, because that's what's going to get you, and you might get it wrong if you forget those. So it has 5 faces, and how many edges? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. So let's take a look at another one of the activities that you're going to be doing for this week. This talks about investigating 3D objects. So if we look at this object up here, it says when 2 surfaces meet, they make an edge. So we already know that, right? Our edges are right here. These lines right here. When 3 or more edges meet, they make a vertex. So remember, our vertexes are our little corners, right? And when there is more than one vertex, they are called vertices. How many edges does this object have, and how many vertices does it have? Now, like I said, what I like to do is I like to act like I can grab it out of the computer, and now I like to act like I'm holding it in my hand. Or maybe if you look around your house, you might find something that looks like this object that maybe might make it easier for you to try to figure out how many edges it has or how many vertices it has. So first, together, I want you to take a second, and I'm going to take a second, and we're going to count how many edges do we see. So we're going to count how many of these straight lines do we see. Don't forget that there's a bottom, and don't forget that there's 2 sides right there as well. Okay? So I'm going to just give you a few seconds. How many edges do you see? Or how many does it have? Okay, so if I counted, I said I like to kind of just do it where I don't confuse myself. So I'm going to go top, bottom, and then sides. So I go 1, 2, 3, 4. Then I go to the bottom, 5, 6, 7, 8. So I already have all those. Then I count my sides, 9, 10, 11, 12. Okay? How many vertex do you see? All right, so let's count. I see 1, 2, 3, 4, 5, 6, 7, 8. Hope that's what you got. All right, let's look at this cylinder. Now, this is going to be a little bit different because this one doesn't have flat surfaces or flat faces like this. And it might not have something else too that I'm looking at it. Is there something else that you see missing from the cylinder that this has? Well, let's see. First question is, how many edges does it have? So how many edges do you see? Remember, when 2 surfaces meet, they make an edge. How many edges do you see? How many vertices do you see? So to me, it didn't have the edges like what we were used to, but it did look like it had a curved edge. So it looks like there's one curved edge. There's another curved edge. Oop. So it looks like we might have had 2 curved edges. All right, so let's look at the next page. We just did one together on this page. Let's look at this page. So let's look at C, because we haven't really talked about that. Excuse me. We haven't really talked about that shape. So let's go ahead, and it wants us to look at our vertices first. So let's go ahead and count them. Remember, those are our corners. So we have 1, 2, 3, 4, 5, 6. Do you guys see any more? All right, so we'll put 6 here. Straight edges. Remember, our edges are our lines. How many straight edges do we see? Let's count them. Or you count them, and then I'll count them, and we'll see if we have the same amount. All right, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I hope I'm not confusing you by the way I count. But if I told you already how I was counting, but I will tell you again. So instead of just going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I find a shape and I count I count by the shapes. So like I saw the 2 triangles, so I count those first. So I say 1, 2, 3. Then I move over, I see my other triangle. So then I say 4, 5, 6. Then I know that I've already counted this triangle and this triangle, so I only have these 3 lines left. So 7, 8, 9. All right, our next one says curved edges. Does this have any curved edges? Looks all straight to me. Only time you're going to see curved edges is if you have some type of circle in there. What about flat faces? How many faces, how many flat surfaces do we see on there? Go ahead and you count. All right, so let's count. So we have the first triangle 1, the second triangle 2. We got this rectangle right here 3. I see another one on that side 4, and then we can't forget the bottom 5. So we write 5. And how many curved surfaces? 0. I don't see any curved surfaces. Okay, so let's look at the bottom. It says, imagine you sliced a corner off a cube. Complete this table. So it doesn't want to know about the cube. It wants to know about the side of the cube that you sliced off. So you have to look. Oh, so I guess it wants you to do, so that's my bad. You have to look at the large piece and the small piece. When you look at the large piece, it wants you to act like this piece was not there. So you got to cover it up with your hand and count your edges, your number, and your faces, okay? When I say large piece, I mean the big piece. When I say small piece, that's this little chunk right there, okay? So you're doing exactly what you did up here. You're just going to act like that piece was removed. So if it asks you how many, let's go with faces. So we just act like we have a big box. How many faces does a big box have? It has 6. 1, 2, 3, 4, 5, 6. Even with this sliced off, it's still going to be 6. So you would write your 6 right here. I haven't. Let's write our 6 right here. Make the box a little bigger. And so you would do the same thing when it comes to your vertices and everything else. You may have more, you may have less, because it looks like when I count my vertices, normally I would just have 1, 2, but since that's sliced off, it looks like I'm going to have 1, 2, 3, 4, 5 on this side. So just try your best on that one. All right, and I think that is it for the week.